Did you know there are over 1 million asteroids zipping around our solar system that we know about? And that's just the ones we've spotted so far. Most of them are just lonely lumps of rock and metal tumbling through the void between Mars and Jupiter. But what if I told you that one of these space rocks could be our next great frontier? Not just a place to visit, but a place to live. Imagine hollowing out a giant spinning potato in space and turning it into a bustling city, a safe harbor for humanity. It sounds like something straight out of a science fiction movie, doesn't it? But the science behind it is surprisingly solid. It's a truly mind-boggling idea, but one that scientists and engineers are seriously considering for our future among the stars. This isn't just about planting a flag and a few scientific instruments. We're talking about building a permanent home, a self-sustaining ecosystem tucked away inside a celestial boulder. The sheer scale of the challenge is immense, but the potential rewards are even bigger. An asteroid base would be a completely new kind of human settlement, unlike anything we have ever built before. Forget domes on Mars or floating stations orbiting Earth. This would be a habitat protected by kilometers of solid rock, offering a natural shield against the harshness of space. It's a bold, audacious plan that could redefine what it means to be a spacefaring species. It's the ultimate off-world real estate venture. So, why go to all the trouble? When you think of living in space, you probably picture something like the International Space Station. It's a magnificent piece of engineering, a collection of shiny white modules floating gracefully above our planet. But living on the ISS is like camping in a very sophisticated, very expensive tent. You are constantly exposed to the dangers of space, shielded only by a few thin layers of metal alloy. An asteroid base, on the other hand, would be more like a fortified castle. Instead of being vulnerable on the outside, we would be nestled safely on the inside. The sheer bulk of rock surrounding our habitat would provide a level of safety and security that is simply impossible for a traditional space station to achieve. The key difference is using the environment itself as our primary building material and shield. On the ISS, every single gram of material had to be blasted into orbit from Earth at enormous cost. With an asteroid base, the main structure, the rock, is already there waiting for us. Our job is to be cosmic renovators, not builders from scratch. We would become space miners and engineers, carving out living spaces, laboratories, and hydroponic farms from the asteroid's interior. This approach, known as in situ resource utilization, or ISRU for short, is the secret sauce that makes the whole idea financially and logistically more feasible for long-term settlement. So, we've picked out our perfect asteroid. The next big question is, how do we get there? It's not exactly a weekend trip. Our target would likely be a near-Earth asteroid, one whose orbit brings it relatively close to our own planet. Even so, close in space terms can mean millions of kilometers. The journey would be a long and carefully planned expedition, taking several months or even a year, depending on the orbital mechanics and the propulsion technology we use. The spacecraft carrying the first wave of robotic builders and human pioneers would need to be a marvel of engineering, a self-contained ark for the long voyage through the black. The ship itself would likely be propelled by advanced systems, far more efficient than the chemical rockets we use to escape Earth's gravity. Think solar electric propulsion, where massive solar panels collect sunlight to generate electricity, which then powers incredibly efficient ion thrusters. It's the ultimate cosmic tortoise versus the chemical rocket hare. While the initial acceleration is slow, over months, an ion drive can build up tremendous velocity, making it perfect for long-distance cargo and crew missions without needing colossal amounts of fuel. Once we arrive, we can't just slam on the brakes. Approaching and matching speed with a tumbling chunk of rock is a delicate celestial dance. All right, we've arrived. Our new home is a giant, lumpy rock floating in space. Now for the fun part, the construction. How do you dig a hole in something that has virtually no gravity and is as hard as, well, rock? You can't just bring a shovel and a wheelbarrow. The first step would be to anchor our equipment to the surface. We'd use powerful drills and harpoon-like anchors to secure a base camp, a small, pressurized habitat where the first engineers can work. From this beachhead, the real work of excavation begins. We would deploy an army of specialized mining robots, our cosmic construction crew. These wouldn't be your average diggers. They would be designed to operate in zero or microgravity, perhaps using specialized gripping claws or magnetic feet to cling to the rock. Instead of brute force excavation, we might use more advanced techniques. One idea is to use focused solar energy. A large mirror or lens in orbit could concentrate sunlight into an intense beam, heating the rock until it cracks and vaporizes. This thermal fracturing would be a clean and efficient way to carve out tunnels and caverns without the violent, unpredictable mess of using explosives, which could potentially shatter our entire new home. It's like using a giant magnifying glass from the sun to carve our city. Creating a beautiful cavern inside a rock is one thing. Making it livable is another challenge entirely. To survive, we need the basics: breathable air, clean water, and a steady supply of energy. So let's start with air. We can't ship bottles of oxygen all the way from Earth forever. That's just not sustainable. The solution lies in the rock itself. Many asteroids, particularly the carbonaceous chondrite type, are rich in water ice and oxygen-bearing minerals. Our mining robots would seek out these resources. By heating the water ice, we can collect the water and then use a process called electrolysis to split the water molecules, H2O, into hydrogen and breathable oxygen. It's high-tech chemistry on a cosmic scale. Life inside an asteroid would be safer than on a space station, but it wouldn't be entirely without its dangers. One of the biggest threats in space is radiation. The sun and distant cosmic events constantly bombard our solar system with high-energy particles that can damage our DNA and cause serious health problems. Here, our asteroid home is our greatest ally. Several meters of solid rock provide an excellent natural shield, absorbing the vast majority of this harmful radiation. This is a huge advantage, allowing for long-term settlement without the chronic health risks faced by astronauts on missions in deep space. Living inside an asteroid isn't just about survival. It comes with some truly unique and amazing benefits. For starters, an asteroid base would be a scientific goldmine. Asteroids are pristine time capsules from the birth of our solar system, about 4.6 billion years ago. They contain the original building blocks of planets. By studying the asteroid from the inside out, we could unlock incredible secrets about how Earth and the other planets were formed. So let's close our eyes and really imagine it. You wake up, not to the sun rising, but to the gentle simulated daylight brightening the ceiling of your cavern home. The sky above you is actually the other side of the massive curved cylinder you live in, with parks and buildings clinging to it. You feel the gentle pull of spin gravity as you get ready for your day. What job would you have in this rock-bound city? Would you be a geologist exploring new tunnels to analyze the asteroid's ancient composition? Perhaps you'd be a hydroponic farmer, tending to the crops that feed the entire community. Maybe your passion is robotics. You could be an engineer who maintains the army of mining and construction bots that are constantly working to expand the habitat or harvest resources from the surface. Or perhaps you're a teacher in the city's school, teaching children who have never known the full gravity or blue sky of Earth. The idea of hollowing out an asteroid and calling it home might seem like a far-fetched dream today, on August 3rd, 2025. But so did flying, or walking on the moon, or carrying a supercomputer in your pocket. The history of science and engineering is a story of turning the impossible into the inevitable. Building a city inside an asteroid is more than just an engineering challenge. It represents a fundamental shift in our relationship with space. It's about graduating from being planetary visitors to becoming true citizens of the solar system, using its resources to build a lasting and sustainable future. These asteroid bases would be more than just isolated outposts. They would become nodes in a vast interplanetary network. Imagine a chain of these habitats stretching through the asteroid belt, forming a highway to the outer planets. They would be refueling stations, manufacturing hubs, and scientific laboratories, each one a testament to human ingenuity. They would be our arcs in the cosmic ocean, ensuring the long-term survival of our species by spreading it beyond the confines of a single fragile planet. If a catastrophe were to ever strike Earth, these asteroid cities could be humanity's lifeboat. The children born inside these rocky worlds would be a new kind of human, the first true spacers, with a perspective on the universe that we can barely comprehend. The sky for them would not be blue, but a star-filled dome of rock and technology. Their resourcefulness and their understanding of closed-loop systems would be second nature. They would be the generation that takes the next steps, that ventures from the asteroid belt to the moons of Jupiter and Saturn, carrying the torch of exploration even further into the dark. Ultimately, the quest to build an asteroid base is about answering one of humanity's oldest questions. Are we alone, and what is our destiny? By pushing ourselves to live in such an alien environment, we learn more about ourselves, our resilience, our creativity, and our unquenchable thirst for knowledge. It's a vision of a future where humanity is not confined to one world, but is a dynamic, spacefaring civilization. It all starts with a simple, crazy idea: to take one of the countless rocks drifting in the darkness and transform it into a beacon of life and hope. And that is a future worth building.